Welcome back to Summarize Science. Astronomers are planning the next great space telescope, the Habitable Worlds Observatory, or HWO, to search for signs of life beyond Earth. But there's a huge problem. Building these giant, complex observatories is incredibly difficult, risky, and expensive. This paper argues that it's time for a revolution in how we design them, by embracing what the author calls Space 3.0. To understand this, the paper divides spaceflight into three distinct eras, or space ages. Space 1.0 was the pioneering era of the 1950s and 60s, with a just-make-it-work attitude. We are currently in the middle space age, or Space 2.0, which began after the Apollo 1 tragedy. This era's motto is "Failure is not an option," leading to incredible but extremely complex and expensive one-shot missions like the James Webb Space Telescope. The paper argues we are now entering a nascent new space age, or Space 3.0, defined by cheaper commercial launches and the ability to service and upgrade hardware directly in orbit. A major problem of the Space 2.0 era is what the author calls the tyranny of the fairing. This means the entire, fully completed observatory has to be folded up to fit inside a single rocket nose cone. It must then survive the violent launch and unfold itself perfectly in space, with virtually no way to fix it if something goes wrong. So how can the ideas from the coming Space 3.0 era help build the Habitable Worlds Observatory? The core idea is to move away from launching a single, perfect, and unchangeable machine. Instead, we can design the observatory as a sustainable platform that can be assembled, repaired, and upgraded over its lifetime. The author created this table to show exactly how these new concepts can solve the biggest challenges in building a flagship mission. For example, the column servicing, assembly, and logistics is shown to help with almost everything, from reducing risk to lowering long-term costs and preventing technology from becoming obsolete. Other advancements like cheaper launchers and better communication networks also play a huge role. This approach can tackle challenges that have made previous missions so difficult. What does this actually look like? Imagine launching the main telescope first, and then sending up new, more advanced science instruments a few years later on a separate, cheaper flight. If a critical component fails or a solar panel gets damaged, a robotic servicing vehicle could fly up and replace it. We could even assemble a telescope in orbit that is far larger than anything that could fit in today's rockets. So let's recap the big picture. The central argument of this paper is that the design philosophy for our next great observatories must evolve. Instead of building a single, static instrument, we need to embrace the Space 3.0 approach of creating upgradable and serviceable platforms in space. This shift could make future missions less risky, more powerful, and scientifically productive for decades longer than they are today. It represents a fundamental change from a one-and-done mission to a sustainable presence. As the author powerfully concludes, "I don't want to wait. Let's get the revolution started."